In the not-so-distant past, ice makers lasted for the average life of a refrigerator. But now, with all of our advances in marketing technology, they last about 5 years. So before you sink a bunch of cash into a repair, inspect every part of the ice maker for damage, especially the Teflon-coated ice mold, which is common to break down and corrode. I hate to say it, but because ice makers have such a short life expectancy these days, more often than not, replacing your ice maker is the most cost-effective form of repair. Fortunately, replacing an ice maker is extremely simple, and you can save $100 to $150 by doing it yourself. First, unplug the refrigerator. The ice maker is held in place by 2 or sometimes 3 quarter-inch screws. To remove the ice maker, loosen the 2 top screws that hang the ice maker to the freezer's sidewall. The bottom screw, if there is one, must be removed completely, allowing the ice maker to be lifted from the 2 top screws. After the ice maker is loose, you can disconnect the rear wire connection. To reinstall your new ice maker, just run that in reverse. You may also need to swap out the wiring harness to match up with the plug of your refrigerator. See, that wasn't so bad. But before you go and buy a new ice maker through ApplianceAssistant.com, it would be wise to understand the cause of the failure so that you know you're on the right track. Please excuse my shameless plug. There have been several different ice maker designs through the years. All have the same basic mechanics, but some minor mechanical variations. In this video, we will be looking at the extremely common Whirlpool-built modular ice maker, installed in almost all Whirlpool-produced refrigeration, which includes Maytag, KitchenAid, Roper, Estate, and Sears Kenmore, just to name a few. Ice makers are like a separate appliance in your freezer. They have their own control system, timing, and mechanical components independent for the most part from the rest of the refrigerator's functions. On average, the ice maker will produce 1 batch of ice every 1 to 2 hours. As I discussed in the circuit training video, all appliances have a power source, conductor, control device, and a load that actually does the work. With an ice maker, there are 3 control devices: the thermostat, the bail arm switch, and the ingenious rotating gear switch. There are also 3 loads: the motor, the water valve, and the mold heater. We will look more closely at each of these in a moment. First, insert your screwdriver into the water supply tube that carries water from an automatic water valve to the ice maker through the freezer's rear wall. This tube can freeze solid, blocking any water from filling the ice maker's mold and stopping ice production, even if the water valve is being energized. If this tube is frozen, thaw it out and hope for the best. If it soon refreezes, you may need to replace the automatic water supply valve, not necessarily the ice maker. Ice buildup in this tube usually means that the water valve is not closing completely and slowly seeping water builds up in this tube. As I mentioned, the ice maker temporarily energizes an automatic water valve behind the refrigerator for about 7 seconds. When the solenoid is energized, it lifts a small internal gate allowing 4 to 5 ounces of water to flow into the ice maker's mold. Some refrigerators have water filtration systems that remove all those pesky contaminants, which is good because minerals in the water can cause the extremely thin coating on your ice maker's mold to break down even more rapidly. The mold coating is important because it allows ice to slip from the mold easily. If it breaks down and becomes rough or flakes off completely exposing the metal, the ice will jam in place and you will need to use those plastic ice cubes at your next cocktail party. Water filters are designed to be replaced every 6 months or approximately 400 gallons of water filtration. If the water filter or filter housing becomes clogged, the amount of water reaching the ice tray may be reduced, causing smaller or hollow ice cubes. If the refrigerator has a water dispenser, a quick way to check the water volume is to dispense water into an 8-ounce glass. It should take 15 seconds or less. Reverse osmosis, or RO systems, can cause similar problems, giving the user excellent water quality but very low water pressure. After the ice maker is filled with water, we wait. Rushing nature is fine sometimes, like when you really want yesterday's pizza hot in 30 seconds, but removing heat from water takes a little more time. Once the thermostat senses that the water has frozen, it closes a circuit, energizing the motor and heater. As the timer advances, the ice sensing arm raises and the harvesting arm rotates until it comes in contact with the ice. The motor is unable to move the ice until the heater loosens it from the mold. When the heater has done its job, the harvesting arm continues its rotation. After the ice has been removed from the mold, the thermostat reopens. The ice sensing bail arm will now attempt to drop. However, if it is blocked from completely dropping to its neutral down position, power will not be supplied to the motor and the ice maker will stop production. In this way, the ice maker can sense if the ice container is full, opening a circuit and stopping ice production. The ice maker is a fairly simple mechanical device made of 6 main components. The control module, which contains a small motor that drives a gear with a conductive pattern on the back. energizing various components at the proper times as it rotates. The harvesting arm, which removes formed ice cubes. The ice maker thermostat is normally open and closes temporarily when the ice is frozen, energizing the mold heater and causing the motor to rotate again. The mold heater warms the mold, causing the ice cubes to melt slightly for easy removal. And the bail arm opens and closes a small contact inside the control module, interrupting power if it senses that the ice bin is full. Lastly, the water valve supplies the high-quality H2O necessary for ice production. This style of ice maker has a few test points on the module which enables us to test some components without removing the ice maker. For more information on how to use a voltmeter, visit applianceassistant.com. First, we will check the mold heater. Set your meter to measure resistance and insert the meter leads into the L and H terminals. The mold heater should give you a reading of around 72 ohms of resistance. Next, we can check the timer motor by inserting our leads into the L and M test points. You should get a reading of around 4,400 ohms of resistance. The water valve can be checked from the valves test points, which are N and V. And this is a good one to know, because you can test the water valve without removing the refrigerator, and you should get a reading of between 150 and 350 ohms of resistance. And lastly, the thermostat can be tested from test points T to L. Remember that ice must be present in the ice maker's mold for the thermostat to close. Just cold is not good enough. So now let's talk about the size of your cubes. Ice makers don't have any kind of water level sensor like a washing machine does. Instead, they fill for a set period of time, as the rotation of the timer temporarily energizes the water valve. Ice makers are set at the factory for an average household water pressure. However, if you start to have problems like individual ice cube groups being connected along the top after they've been harvested, or icicles hanging down from your ice maker, or your ice container floor being covered with ice, all of these are symptoms that are caused by too much water. If you have small cubes, don't be embarrassed. You're just not getting enough water. You can correct both of these problems by adjusting how long the valve is energized with a screw that is located on the ice maker module. Adjustment is clockwise to reduce fill time and counterclockwise to increase it. But be careful, a little goes a long way. One full rotation is the most that you should ever need. You can see how far from the factory setting you are with this little window. The hole is centered at the factory. Well, that about sums it up. I hope this video was helpful and saves you a lot of money. More videos like this one and other appliance repair help are available at applianceassistant.com. Thanks for watching. In the not-so-distant past, ice makers lasted for the average life of a refrigerator. But now, with all of our advances in marketing technology, they last about 5 years. So before you sink a bunch of cash into a repair, inspect every part of the ice maker for damage, especially the Teflon-coated ice mold, which is common to break down and corrode. I hate to say it, but because ice makers have such a short life expectancy these days, more often than not, replacing your ice maker is the most cost-effective form of repair. Fortunately, replacing an ice maker is extremely simple, and you can save $100 to $150 by doing it yourself. First, unplug the refrigerator. The ice maker is held in place by two